Right, so now let's talk about 6.2, so which is going to be double angle formula. For example, if your original angle is given by theta, so now we're going to have a look what you have twice of the theta, which is going to be 2 theta. So there are going to be three different formulas individually for each trigonometric function: sine, cos, and tangent. But however, cos 2 theta, so it has three properties that can be related to the double angle. So you can actually write it: cos 2 theta is going to equal cos square theta minus sine square theta is actually also equivalent to 2 cos square theta minus 1, and it is also equivalent to 1 minus 2 sine square theta. So basically, when you have cos 2 theta, so you can write it either in one of these three forms. And of course, these three forms are related. So actually, they are derived from this formula, and by applying the identity, so the fact that sine square theta plus cos square theta is equal 1, so you can actually come out with these two formulas. So that is how we come up with all the three properties. So I'm going to demonstrate on how to use the double angle formulas by using this particular example. So for example, let's say if we have sine theta is equal 5/13, and theta is actually an angle between pi/2 to pi. So knowing that theta is between pi/2 to pi, so we know that theta is going to be in the second quadrant. So we're going to find the exact value of sine 2 theta, cos 2 theta, and also tangent 2 theta. So let me sketch this first. So if I were to sketch this, so it's going to be in the second quadrant. So this is where the position of theta is. It's going to be theta somewhere over here. And according to the trigonometric rule, the fact that sine, the SOHCAHTOA rule, sine is going to be opposite over hypotenuse. And according to the equation that we have over here, opposite is going to equal 5. So I'm going to have a 5 over here. And hypotenuse, the value is going to equal 13. And I also going to need the value of the adjacent. And according to the Pythagoras theorem, so the adjacent value is going to equal 13 square minus 5 square square root. So that is going to be a value of 12. So I'm going to have a 12 over here. So now that I already know all the values, the hypotenuse, the opposite, the adjacent value, so what we can do is we can come out with all the trigonometric function. I'm going to use this triangle that we had in order to find what is going to be sine theta, cos theta, and also tangent theta, so that we can use this in order to find the exact value of this three trigonometric function. Okay, so from the question given, so we already know that sine theta is going to equal 5/13, and it's supposed to be positive because remember, when we are in second quadrant, according to the cos rule, so only sine should be positive. Anything else is going to be negative. And anything else, I'm referring to the cos and also the sine, the tangent. So then I'm going to have cos of theta. Cos is going to be ka adjacent, so which is going to be 12 over hypotenuse. So that's going to be 12/13. But this is going to be negative because in the second quadrant, only sine is supposed to be positive. And then we also have the last trigonometric property, which is going to be tangent of theta. And according to the rule, tangent of theta is going to be TOA, opposite over adjacent. And that is going to be, opposite is going to be 5, and adjacent is going to be 12. And of course, it's going to be negative 5/12 because tangent is only positive in the third quadrant. But we are now in the second, so it's going to be negative. All right, so now using all this information that we had, so I'm going to find what is going to be sine theta, cos 2 theta, and also tangent 2 theta. So let's start with the first one, which is going to be sine 2 theta. So according to the rule, so sine 2 theta, according to the formula that we have seen previously, is going to equal to sine theta cos theta. So now all we have to do is substitute the value. So sine theta, according to what's given, is 5/13, and cos theta is going to be negative 12/13. So I'm going to have negative 12/13, and use your calculator for that. So I'm going to have 2 multiplied by 5/13. So multiplied by a negative of 12/13. So that is going to give you a value of negative 120. And that is going to be over 169. Okay, so that is going to be sine of 2 theta. Okay, after we're done with that, I'm going to proceed to B, so which is cos of 2 theta. As I mentioned just now, for the case of cos 2 theta, it's a very special case for which you can either pick any one of this. You can either pick this one, and this one, but no matter which one do you pick, it's always going to give you exactly the same answer. So if I were to pick this one, I have to replace both cos and sine. So that is why I'm going to pick from any of these two, but I decide that I'm going to pick from the second formula. So you can choose either one, the second or the third. But if you choose this one, you have to replace both cos and also sine. I don't want to do that. I'm only going to replace one value. So therefore, I decide to use this formula right here. So I'm going to have a 2. So cos, I would like to remind you, so the fact that cos square theta is actually cos theta that is being squared. So that is why when I replace this value, so what is cos theta? According to what we have calculated, cos theta is going to be negative 12 over 13. So I'm going to have 2 multiplied by negative 12 over 13 raised to the power of 2 minus 1. Okay, when I use my calculator, I will get 2 multiplied by negative 12 over 13, and that is raised to the power of 2 minus 1. So that is going to give me a value of 119, and that is going to be over 169. So that is going to be cos of 2 theta. And then I'm going to proceed to tangent 2 theta. So of course, for the case of tangent, the formula is going to be slightly more complicated because we have it in terms of a fraction. So I'm going to have 2. So tangent theta, according to what we have calculated, is going to be negative 5 over 12. So I'm going to have negative 5 over 12. And that is going to be over. So 1 minus negative 5 over 12 raised to the power of 2. Okay, so I'm going to end up with, at the top, I'm going to have negative 10 over 12. So divided by, at the bottom, I'm going to have 1 minus negative 5 over 12 raised to the power of 2. Okay, and from the calculation, I get a value of negative 120. And that is over 119. Okay, so that is going to be tangent of 2 theta. Right, so I think that it's not that hard for this kind of question. I think the tricky part is you to figure out all these 3 values. So once you figure out all these 3 values, so I think using the formula is not going to be something that is too complicated. All you have to do is substitute, press your calculator, and get the value. That's it. Okay, now, so I would like to proceed with these 2 examples. Okay, for the first example, so I'm going to find the exact value by using the second angle formula. I'm going to find the exact value of 2 tangent of 15 degree over 1 minus tangent square of 15 degree. Okay, the thing about exact value is that when a question said to you, find the exact value, so it must be something that got to do with this special angle formula. So 30, 45, and also 60. Okay, how do we relate? So we know that special angle is going to be 30. So it could be 45 degree. So it could be 60 degree. And how are we going to supposed to relate that with 15 degree? Because we know that 15 degree is actually going to be 30 divided by 2. And we can actually, or this is going to be twice of that 15 degree. So that is going to be 30 degree. And because of that, we are going to use the double angle formula. Okay, so this is the question. So I can, upon comparison, what I'm going to do, I'm going to compare both of this. And upon comparison, I can tell right away that for this case, my theta value, that is going to equal 15 degree. And according to the formula, so if I have this, it's going to equivalent to 2 theta. So we can actually write that. So 2 tangent of 15 degree over 1 minus tangent square of 15 degree. So that is going to be equivalent to tangent of 2 times theta. And because our theta is 15 degrees, so that is going to be 2 multiplied by 15 degree. And 2 multiplied by 15 degree is going to be 30 degree. Okay, so I'm going to end up with tangent of 30 degree. Of course, because 30 degree is actually a special angle, so we can get the exact value. So tangent of 30 degree is going to be given by this, which is square root 3 over 3. So this is going to equal square root 3 over 3. So that is going to be the exact value of 2 tangent 15 degree over 1 minus tangent square 15 degree. Okay, next. For the last example, so we're going to be proving this, that cos 3 theta is going to equal 4 cos cube theta minus 3 cos of theta. So I know that for this case, we are going to have to use multiple properties in trigonometric in order to prove this. But let's start now. Okay, so first of all, the thing that I would like you to notice is I'm going to the other way around now. So usually what I will do is I start with a more complicated one and I will make it like simpler. But for this case, I'm going to do it the other way around. So I'm going to start with cos of 3 theta. And I'm going to prove that that is going to equal 4 cos cube theta minus 3 cos of theta. Because I know, actually this might look simple, but it is actually a very complicated formula. And of course, 3 theta, there's no formula that relates 3 theta. But actually, there is a formula that can relate to the double angle 2 theta. So that is why I'm going to change the form. So I'm going to write that. So cos 3 theta is actually equivalent to cos of 2 theta plus theta. So according to the function, so you can change it any way you like as long as these two are going to be the same. Of course, when I add these two together, it's going to come to being 3 theta. So I don't change the value, it's still going to be the same. Okay, now I have in the form of cos 2 theta plus theta, I'm going to apply the addition formula for cos. So I know that if I have cos of A plus B according to the formula, so that is going to be equivalent to cos A cos B minus sin A sin B. And what is my A? That will be 2 theta. And my B is going to be theta. So let's apply the formula. So I'm going to have cos of 2 theta cos theta. So minus sine of 2 theta sine theta. Okay, so that is what I got from applying that. And then I noticed that I end up with a double angle formula. So I got cos of 2 theta. I also have sine 2 theta, for which I can actually apply the double angle. So now let's start applying the double angle. So cos 2 theta according to the formula is going to equal to, my pen is really not smooth these days. I'm going to have 2 sine theta cos theta. Okay, so multiplied by the cos theta outside. And then minus, I come across sine 2 theta. Oh, sorry, that is actually wrong. So let me correct this. That is not right. So I wrongly copied the different formula. So cos 2 theta is actually cos square theta minus sine square theta. So multiplied by cos theta. So that's the first term. And sine 2 theta is actually going to be the one that is equal to sine theta cos theta. And multiplied by sine theta. Okay. Right, so I'm going to expand this bracket right here. I'm going to remove it and have a look whether or not it's going to be like we are on the right track of actually showing that these two are equivalent. So when I expand, I'll end up with cos cube theta for the first term, minus, and then I'm going to have sine square theta cos theta. And at the back, I'm going to have a minus 2. So sine multiplied by sine, that is going to be sine square theta. So multiplied by cos theta. So that's how it looks like. And of course, if you notice, so these two, they are actually the same. This is sine square theta cos theta. So that is actually twice of that. So negative 1 minus 2. So that is going to be minus 3 of that function. So I can actually simplify this too. So cos cube theta minus 3 sine square theta cos of theta. Okay, but the problem is that when I compare to what I have at the top, of course, I have something in the form of cos cube theta. But I have both of the term at the top right here is in term of cos. So therefore, I have to get rid of the sine. And I'm referring to the sine right here. And I know that there is a formula that we can relate between sine and cos. And that is going to be the identity that we always use, which is sine square theta plus cos square theta equal 1. So I'm going to try to apply that and see if they are going to be equal. So I'm going to have cos cube theta minus 3. So sine square theta, according to identity, is going to equal 1 minus cos square theta. So multiplied by cos theta. So now let's simplify this. So I'm going to have cos cube theta minus 3 cos of theta and plus 3 cos of cube theta. Okay, so that's how it's going to look like. And of course, these two, they are the same. So I'm referring to these two over here. So which term are both in term of cos cube theta? So I can actually put them together. And I can write that they are going to equal 1 plus 3, that's a 4. So 4 cos cube of theta minus 3 cos of theta. So when I look at what I have at the top over here, so they are actually the same. So this is proven. So I have proved the fact that cos 3 theta is actually equivalent to 4 cos cube theta minus 3 cos of theta. So the way to do this is not obvious. Like, you have to be careful at selecting which formula that you're going to use. But once you actually do a lot of practice, so that will come naturally to you. So which formula is going to fit which condition. And of course, when it comes to proving, there are multiple ways of doing this. This is not the only way of proving the equation, but you could also come up with any other way as long as you get that the left hand side and the right hand side are actually equal. Right, so as usual,